Okay, for today, the main topic is to finish about the discussion on two-dimensional arrays. I'm going to release lab number 6, hopefully this Friday, so you can start doing that. Okay, so last time we talked about two-dimensional arrays. Basically, it's just an array of arrays. Let's review the motivating example we talked about, and I'm going to go over the solution with you in very much detail. And then we'll talk about a number of different algorithms or different methods manipulating two-dimensional array. Hopefully that will get you prepared for lab number 6. Okay, the motivating example we talked about last time was this one here. So basically we are given two dimensions over here. The first dimension is basically the row over here. You got different cities as the departure city. And also you got the second dimension over here being the destination cities. So now the problem is, if you want to have some itinerary for your traveling plan, what should be the distances in total involved? So that's kind of the problem we are solving. Of course, this is only one particular example. For your lab number 6, it will be another kind of example, but they both use two-dimensional array. Okay, so we talk about this example over here, and we also talk about how you would solve it without the two-dimensional array. Okay, I'll leave you to that. So I posted the 2 versions of source code in the course website. You can just go over them by yourself. I'm going to go over with you the second version using two-dimensional array in very much detail today. Just make sure you're comfortable with it before we go on with other examples. Okay, so now let me just go directly to the example over here. Before I do that, let me just remind you about what kind of example we are trying to solve. Okay? Before I demonstrate to you, let me just go to iPad over here. Let's just do a little warm-up over here. So this is basically, so I'm talking about the solution for your motivating example over here. I divided that into 3 parts, which we can go one by one. The first part is really the most critical one. You're defining the data structure for you to use to solve the problem. So over here, we have a 2-dimensional array. So basically, it will be distances. Let's assume every time we talk about the distance between 2 cities, it's just integer. Or we can change it to double if you like. Okay, we got a 2-dimensional array. And now over here, the way we do it is by opening with curly brackets and closing with another curly brackets. And for each row, we got a pair of curly brackets like this. Maybe let me use different color over here for each row. So that's the first row, row number 0, row number 1, and row number 2, and etc. Okay, that's how you initialize a 2-dimensional array. Okay, you might do something similar for your lab number 6. So now, let's answer 2 questions just to help us understand how to interpret this particular structure. Question number 1: how do you look up the distance between, let's say, Miami and Boston? First of all, you have to figure out if Miami and Boston over here are valid names for the cities. If they are not, there's no way for you to look it up. Otherwise, you can. Okay. In this case, Miami, yes, it is. Let me use a different color here. So now, in this case, remember the row number are simply the row number is the departure city, and the column number is the destination city. And in the very beginning of the program, we try to define constants for each index for the city. In this case, Miami, we do have it. So Miami has this particular integer index 4. Okay, that means if you go to row number 0, 1, 2, 3, 4, so this row over here corresponds to Miami. Okay, and then for Boston, similarly, you can see Boston over here has the index 1. In that case, you know that the column number here, you can see, let me say this. This would be the row for Miami. So this is the row. Let's say this will be all the distance departing from Miami. Okay, that would be it, because it's 0, 1, 2, 3, 4. Okay, you can just say implicitly these are the row number. And then how do we get to Boston over here? So in this particular blue row, we want to go to the corresponding column for Boston. And for Boston, we know that it's going to be of index 1. So now, how do we look it up? So let's use orange over here. So you can see this is row number 0 and row number 1. It's exactly over here. Okay, so the answer is it will be 1763. Okay. Let me just say one more thing. Over here, if you try to highlight this part over here, and this part here, what does that mean? All the columns over there, they will be about arriving at, so now you can see, for example, row number 0, row number 1, row number 2, etc. Row number 1 is exactly Boston, arriving at Boston. So now the one we want to solve is departing from Miami and arriving at Boston. So that's exactly this cell over here, right? That's how you use it, okay? Now, let's try to extend the answer to question 1 a little bit. Let's ask a different question, slightly more difficult one. How do you calculate the distances for the following itinerary? Let's say we have just an array of cities, assuming that all the city names are valid. We want to go from Miami, starting from Miami, and then go to Boston, and then go to New York. So that's really the problem we are trying to solve over here, okay? But given that you understand how we manipulate for question number 1, solving question number 2 is just slight extension to it. Basically, you need a loop, and then go from the beginning until the end, and see what's really the distance between. So more precisely, what we're going to see in part number 2 and part number 3 is, given that Miami is a valid city, and Boston is a valid city as well, calculate the distance between, like here, what's the distance between, based on what you learned from question number 1. Similarly, if you go to the next iteration, what will be the distance between Boston and New York over here, and what's that? And add up all the distances together. In general, the itinerary array size can be arbitrarily long, so we want to be as general as possible. Okay? Before we talk about the other 2 parts in details, the code itself looks big, but it's not really difficult. I'll just explain to you in details in just a moment. Let's try to run a test case just to get yourself comfortable with what we want to achieve. You can also try that on your Android Studio. Let's say we want to calculate the following itinerary. Let's say we want to have 3. Let me just use over here. Let's say we want to have 3 cities in the itinerary. We want to start from Miami. Intermediate stop is Boston, and then New York. Let's say that's what we want to do. Okay, let me just illustrate to you on Android Studio. Okay, let's go there. Okay, so it's the version number 2 you have to run. Okay, you will see that on the course website, calculate mileages of itinerary version number 2. That one uses the 2-dimensional array. You will see that for the first part over there, the constant and also the 2-dimensional array, or version number 2, sorry. Let me just go there. Let me double click on that. So for version number 2 over there, you can see that we got a constant for each cities, and also we got the distances as a 2-dimensional array, exactly what we just went over. So let's see how the program is going to run very quickly, and then I'll show you the code in detail. Okay, let's now run this version number 2 over here. Okay, it's been set already, so let me just run. Okay, let's wait for the console. Okay, how many cities? So let's say we want to do exactly what we wanted to do on the iPad. Okay, how many? Let's say we say 3. Let me just do some error checking for you. For this program here, we wanted to have the ability to error checking. Let's say in the 7 cities we talked about last time, there was no Toronto and there was no Vancouver, right? Let's say enter a city there. Let's say Toronto. In this case, even though Toronto is an existing city, but it doesn't exist in the program in the 2-dimensional array. So there should be some error messages printed out. Okay, we'll see that. Let's say enter Vancouver. Also doesn't exist. Okay, let's say New York. Okay, so this itinerary over here, it tells you that it's an error. Toronto and Vancouver, they are undefined as far as the 2-dimensional array table is concerned, right? But we'll see how to do this exactly. Okay, let's try some valid case right now. Let me rerun the program over here, and then I would say, again, 3 cities. Okay, let's say 3 cities. Let's say we got Miami, which exists in the table, and also we got Boston, which also exists in the table. And finally, NY, New York. Okay, if you say that, it tells us that from Miami, the first one, to Boston, we got this much distance. And then from Boston to New York, second to third, we got this much. And added up, this is the eventual distances you got from the itinerary. Okay? Any question about what should be achieved by the program before I go on to the details? Okay, good. So for part number one, we just talked about how you can define the two-dimensional array. That part is rather straightforward. Yes.
What do you mean by error checking? So we check the program, we test so we just test cases where
Yeah. So error checking. What I meant by error checking is as follows. Let me make it more precise over here. You can see over here, if you look at part number one over here, the cities that we intend to support are these. Let me just highlight them. You can see that we want to support for Chicago, Boston, New York, Atlanta, Miami, Dallas, and Houston. Any other cities that, even though they exist in the world, but they are not really covering this particular program. So let's say Toronto. If you enter Toronto as part of an itinerary, that shouldn't exist, right? That's what I meant by error checking. Okay, good. So now, let's have a look at this. Okay, that's exactly the run I just illustrated to you, exactly what I show you. Okay, so now let's have a look at, remember there was also another error case I put. Let me just put it here. So what if, let's say this is case number one, okay? Case number two, I also put Toronto, also Vancouver, and also New York. You can see Toronto and Vancouver, they don't exist, right? We got two cases. For the first case, when you got Miami, Boston, New York, they're all valid. In the second case, Toronto, Vancouver, they are not valid, right? You should be able to handle both cases. Let's now go over the code quickly, okay? So now I'll just use highlighter here, okay? First of all, we got an input scanner, the standard. And then we'll ask the user how many cities you have, right? Exactly what's gonna print it out here. And then this is really the critical counter we need. How many? We want to know exactly how many there are in the itinerary, right? So we'll just read it from the user. And then you can see that we're going to create 3 different arrays accordingly with how many size. I'll highlight them to you. The first one is trip. The second one, trip position, which I briefly talked about last time, but I'll talk about in full details today. And also, we got another one called undefined cities over here. Undefined cities are for error checking purpose, okay? But notice that for all of these 3 arrays, the size are simply how many, and how many. Exactly that, okay? And notice the type for each one of them. For trip, it's gonna be string array. So that means we're gonna store an array of city names. And the trip position over here, that one's the trickiest part for the program. Let's say, for example, if let's say given Miami over here is a string Miami, like a literal. How can we transform the string city name into the corresponding integer index into the 2-dimensional array? For example, if you got Miami over here, we want to somehow transform that into Miami should correspond to exactly position 4, right? Somehow this should be corresponding to 4. But how do we do that? So that's something your program should do. I'll show you. Okay, so that's about the trip position. Okay, and finally, we also got undefined cities. For example, you got Toronto, you got Vancouver. Somehow they should be also stored in this particular array. So we got 3 separate arrays working in parallel. Okay, they're independent of each other. But you can say that these 2 arrays are kind of related to each other, trip and trip position. We'll see. And then we also got a Boolean variable over here to say if there's at least one city name that's invalid. In the first case over here, Miami, Boston, and New York, they're all valid. So that means some city is invalid, should remain false. There's no such city that's invalid. On the other hand, if you got at least one, for example, Toronto, that means you're going to report some error. You just cannot calculate the itinerary distances. Okay? The logic overall is quite clear. It's just that we use many variables over there to work together. That's something you want to spend some time tracing the program. Okay? And finally, we also got something like a number of undefined cities. This counter over here, for those of you, I believe many of you, who have followed the tutorial videos for lab number 5, we keep talking about the number of transactions, the number of course records, or the number of students, right? So this is exactly the counter we are talking about. We want to keep track of how many cities that are invalid so far, and also where exactly should we store into the corresponding array. So that's kind of the counter. Okay? You will see this kind of usage very frequently. That is a very standard use. Okay? Okay, so now let's go into the loop and see what's going on over here. And then I'll show you exactly how this particular case and that one is going to correspond to the program behavior. So we're going to run a for loop for exactly how many times, right? Exactly how many. If you say 3 cities, it'll be 3 times. If you say 5, it's going to be 5 times. Okay? So now we'll say enter a city, okay? And then let me just use yellow here. And then you will read in the city name. You're going to read in Miami, followed by Boston, followed by New York, each one by one in each iteration. So now, I want you to pay attention to this. First of all, you can see that this is how we store the city into the trip array. So now, let me just draw the 3 arrays for you. Because we know that how many, in this case, is exactly 3. Okay? So that means we got the 3 arrays over here. We have the trip array, which has exactly size 3. Each one of them is going to be a string value, initially just null, let's say. And similarly, we also got a second array, trip position. Which element is of type integer. And the default value for integer is simply 0. Okay, so that means 0, 0, and 0, okay, initially. And then also we got something called undefined cities over here, which is also string. Okay, let's say undefined cities. And then it's also going to point to some array over here with size 3 and then initially just null. You wouldn't point to anything until you got your error. Okay, but we'll see. Okay, so now, and also we got a counter over here, number of undefined cities. I'll just put it here. Number of undefined cities. Okay, initially just 0. If it remains to be 0, that means you have no invalid cities from the input. Okay, so now, and then also we got I over here. I is very important. I tells you exactly where to store into the trip and trip position array. Okay, I'll put I over here. I is also very important. Initially just 0. Okay, so these 2 counters are critical. Okay, so now what about this line over here? When we say trip I is assigned to city, in the very first iteration, I is simply 0. That means we want to store into position 0 of this array over here. And then the first input we read, let's say we talk about this test case over here, okay? And the first one is Miami. So that means we're going to say position 0, not rather than pointing to null, is now going to point to Miami. Okay, like that. Okay, and then the second iteration is going to increment I from 0 to 1, which means we're going to store into position 1, etc. So now, what I want you to look at is from here until over here. It's a single big if statement. You can see if, else if, else if, else if, and then we have an else. Okay? Look at what we're doing here. We say city.equals Chicago. By the way, so some of you asked the question about what's the difference between equal versus equals. I'll review this topic maybe next week once we go back to the classes and objects. But for this course, you basically only have to use .equals for string values when you want to compare the contents. But I'll be more systematic next Monday. I'll go back there next time. Okay. So basically, you want to check to see if the current city that's read from the user, if that's really Chicago, or it's Boston, or it's New York, Atlanta, Miami, Dallas, or Houston, each one of them. If it is neither of them, that means you got an error, because none of the 7 cities match. Okay, so now, what if it actually matches one of them? Let's say currently we got Miami over here, so that means we're going to match this particular line. So Miami is over here. So this is going to be true. And all the previous else if and if will be just false. And then if this is going to return true, that means we're going to have trip position I is assigned to Miami. However, notice that this Miami over here, what's its type over here? Be careful. Notice, I'll try to enlarge that for you. When we say city.equals Miami, we have a string literal. On the other hand, when we say trip position and position I is assigned to Miami, it's not of string type, the second one. It's of type integer. How do we get that? It's from over here, from the previous part, Miami, right? That's exactly how we get the position into the two-dimensional array, which means 4, okay? But you wouldn't just use 4. 4 is so-called a magical number, which is much harder to keep track of. So you rather just use a constant name, okay? So now over here, when you say trip position is assigned to Miami, so what that does is I is still 0 at the moment, so that means trip position here, I, which is 0, rather than storing a 0, is going to store 4. How did I get a 4? 4 is exactly from over here. 4 is a corresponding value for constant Miami, okay? So how is the trip position going to be useful? You will see in the third part, okay? The bottom line is, by using the string literal Miami, you cannot get access to the two-dimensional array directly, because you should only access the array using integer indices, but not strings. That's a critical point, okay? Okay, so we keep doing this, and then apparently you can just imagine what's going to happen just for the second iteration. So after the first iteration, we find out Miami, and what about the second iteration? For the second iteration, we're going to see Boston, and Boston is going to match this part here, and then we're going to assign trip position I, which has been incremented from 0 to 1, right? Let me just do the second iteration as well. So from 0 to 1, and then, so that means the trip array over here is going to store Boston. Okay, and then for the Boston, the corresponding index is Boston, which is 1. Okay, so that means we got 1 over here. Okay, that's the second iteration. What about the third iteration? For the third iteration, I will be incremented from 1 to 2. So finally, the third city we want is New York. Let me find a different color here. Let's say for New York, it's going to match this one here, and then trip position I, in this case, is 2, right? So now at position 2 of the trip array, we're going to store New York. So now it's going to store New York. And also we store the corresponding index into the trip position array. So New York is over here 2. Okay, so we got 2 over here. Okay, that's how we run the 3 iterations in the case number 1. Case number 1, all the 3 cases are valid. No errors. That's why you see the number of undefined cities remains to be 0. But I will run just another case for you in just a moment. Any question about this? If you understand this, you pretty much understand this whole example. The third part is rather straightforward. It's just the second part, you have to know why we declare that trip position array over there to store the corresponding indices for the city names. But we'll see. It's very beneficial. Okay? Okay. So now let's run the second case very quickly. Let's say we rerun the program, and now let's say, just show you one. Let's say we got Toronto over here as the first one. If you have Toronto over here, apparently you can see Toronto doesn't match Chicago, doesn't match Boston, doesn't match this, that, none of these. So that means we'll go into this particular else branch, the default case. What it will do is, let me just highlight that. It will do the following. Undefined cities, a number of undefined cities is assigned to city. That means at the moment it's actually 0. That means we're going to store at position 0 of the undefined cities array. In that case, we'll store, so I'll just put it the other way. So rather than pointing to now, it's going to point to Toronto. Okay, and then number of undefined cities will be incremented to 1. And similarly, when we get to the second iteration, when we talk about Vancouver, similarly, right? So Vancouver also does not match any of the 7 cities. So eventually what we will get is, we'll get also here, Vancouver. Okay? And then this will be incremented to 2. Okay? So we got 2 cities that are actually invalid. In that case, that's why when you see over here for the, let me just run it again very quickly. That's why you see from the previous run, if you try to enter any invalid cities, they will print out to you exactly what they are. Let's say 3 cities, Toronto, Vancouver, and also let's say New York, which is valid. But now you can see the error, Toronto, Vancouver are undefined. So how would you print this out though, right? Which I will discuss in this part number 3. It's rather easy, right? Remember one of the example we did for the for loop. Well, to say given an array of names, how do we print it out separated by comma? Exactly used over here. Okay? So now, in this case over here, we have two elements over here. What you can do is, by looking at NOUC, the counter over here, it's larger than 0, which is 2. In that case, we know we got exactly 2 cities that are actually not valid. We can just go over them and then print them out. Okay? That's what part 3 will do. Any questions until now, before I go to the third part? Okay? Again, you should really try to understand why we need 3 arrays over here. Each one of them serves different purposes. Okay? Okay, let's go to part number 3. Part number 3 is basically a very straightforward application of the 2-dimensional array. Yes. Part 2? Okay, guys at the back, please, please. Okay. Which one? Say that again. Oh, okay. Okay, over here. Good question. Yeah. So the question was, what does this line do? Let me just highlight it. Some city is invalid is true. Okay? So now think about where we actually set this Boolean variable to be true. Let me just draw your attention over here. Where do we initialize it? Over here. Let me just find it out. Over here. Boolean some city is invalid is initially false, which means initially let's assume all the cities to be entered by the user is going to be all valid, positive. But now, as soon as we got at least one city that's invalid, that means we just cannot calculate the distances for the itinerary accordingly, right? As long as it's 1. So that's why we just set this Boolean variable to be true so that we can do something with it in part 3. You will see that. It's a good question, actually. I forgot to mention that. So this really, so this indicates if any errors. Okay? So now let's see that exactly how we use it. So now you will see in part number 3, you can see that we say if some city is invalid, if it is true, in which case that has been set from exactly this line over here. If it is true, then we don't do any calculation for the distances. We don't even bother to look up from the 2-dimensional array. We simply print out the errors from exactly this array over here. Okay? And then, if this is true, then we'll simply do the loop over here. That's just standard. I'll leave them to you. We have done this already from the for loop. Okay? The else part is the interesting part. Okay? The else part means all the cities that the user has entered, they're all valid. For example, you got Miami, you got Boston, you got New York. Okay? You got all the 3. Okay, good. Okay, let's now do part 3. So now, in this case over here, we got Miami, we got Boston, we got New York. That means we got Miami, Boston, New York, and also indices 4, 1, and 2. So we can use this information to actually help us look up the table. We'll see. Okay? So now, let's look at the loop. How do we do that? I want you to pay, first of all, some special attention to this condition over here. We still have a loop counter I is assigned to 0, I++ as standard. And then the upper bound is not how many like before anymore. You can see before that we say how many, right? But over here we say how many minus 1. There's a reason for that. Okay, we'll get there. So now I will leave. Let's leave this discussion until the last. Okay, there's a reason for how many minus 1 versus how many. Okay, and now let's try to see exactly what we're going to do over here. So now we can see that we have the source city, the departure city, and destination city. We can simply get access from trip and also trip I+1. Okay, how does it work? Let's have a quick look. So remember, so let's talk about the no error case. So let me just reproduce that very quickly. So we got trip over here, we got 3, and then we got the 3 strings. We got Miami, Boston, New York. Miami and Boston and also New York. And the corresponding position for both for all of them are stored in this array, separate array of type integer. Okay, let me just see 4, 1, and 2. We got 4 here, 1 here, and 2. Okay, so these are the two arrays from part number 2. So next, let's see exactly how this is going to work. Initially, you can see I is going to be 0. For the moment, I is simply just 0. So what does that mean? That means the source CDs over here, let me just do a little bit more careful. We got I here, so we have source and also source CD, and also we have destination CD. Can I just make it a little bit more space for myself? So I here, source CD, and also destination CD, and also we got two other variables in last. And also we got source and destination, which are integers, which we will also talk about together. And also we have source and we have destination. Okay, we got all these. In the case of the first iteration, I is simply equal to 0. So now source CDs will be exactly this value over here, Miami. Okay, so that will be Miami. And then what about destination CD? You just go to the next one, the adjacent one, which means what's next to Miami is Boston. So this is, for example, if this is I, that's I plus 1, the indices, right? So now that will be Boston. And similarly, we also got source and destination. We also use I and I plus 1, the same indices. So also we got I and I plus 1. So now the corresponding indices for source will be 4. And the corresponding index for the destination city will be 1. Okay? That's how we get the information from there. Of course, in the next iteration, I will be incremented from 0 to 1. That means I is going to become over here, and I plus 1 is going to become over there, right? So after each iteration. Okay. So now, let's go on a little bit further. And then, what I want you to look at is this line over here. This line. The distance for the current cities we are looking at is going to be a lookup to the two-dimensional table over here. You can see over here, we got distances over here. So where did we define that? Exactly from part 1, we got distances over here. Okay? And then the way we get access to a two-dimensional array is by passing two indices. Notice that if I simply do the following, if I say distances, let's say I don't have the trip position array. Let's say it doesn't exist from part 2. What I will get is if I simply put source city, which is a string, and also destination city, which is just another string, this would not even compile. That's why we need an indices array. Okay? So that's why you got source and destination here, and source and destination here. Let's just do one example. You can see source is 4, destination is 1. So that means go to row number 4 and go to column number 1. Get to the intersection, 4 and 1. Where is that? Row number 4, 0, 1, 2, 3, 4. This is row number 4. And then column number 1, which is exactly over here, right? Okay, so that's exactly this intersection over here. Okay, that's 1763. Okay, for the first iteration. So that would be 1763 for the first iteration. And of course, you're going to run overall 2 iterations. Why? Because for the first iteration, you calculate what's between Miami and Boston. In the second iteration, you calculate what's between Boston and New York. You always go for I and then I plus 1. That means your upper bound over here, be careful. The upper bound over here should be how many minus 1? What if you put how many? Question for you. What about how many? Index outer bound exception, thank you. Exactly, in the last iteration. Because in the last iteration, how many would be exactly how many minus 1. And then when you get to over here, trip I plus 1, how many minus 1 plus 1 will be how many? And how many wouldn't be a valid index for the array, right? So that's something you want to get used to. Okay? So this is really a very important reason for how many minus 1 over here. Any questions? Okay. One more thing to point out. Over here, you can see that the system of the print line over here, you can see that we're still using the source city and destination city string to print out some messages for the user to read. So therefore, informativeness purpose. But to really calculate internally into the two-dimensional array, you do need the trip position array. Okay. Okay, that's about the motivating example solution. Any questions? That's the code. Okay. Again, as I said, the source code has been made available to you. You should really try to at least play with that, study that, and maybe try to make some modification to see what you can do. For example, adding more cities, or reducing some cities, or try to do some more complicated error handling for yourself. Okay. Can I move on to other examples? Yes.
So basically, like the difference of how many and minus one and how many is that it depends on like the number of codes that we.
The number of, okay, you know what? I want to draw your attention, since the question was maybe still about how many over here versus how many minus one. Remember, there was a problem we tried to solve before for the for loop, which is sorted. Okay, you can look it up in the for loop example. How did we determine if an array is sorted in increasing order, for example? The way we did it was we can say array A, for example, I is less than or equal to I plus 1. So for every adjacent indices of the array, the corresponding element should be sorted, right? That's what we said before. And since we got I plus 1 over here, so the upper bound cannot be the normal A.length anymore. It should be, right? It should be A.length minus 1. The same reason. Okay?
So now that's how we talk about the two differences between how many and how many.
Yeah, so you can think about how many over here. So if you think about trip array, how was it created? If you look at the trip array over here from part number 2, it was created of size how many? So that means trip dot length is exactly how many? Right? So in the case of the sorted problem over there, the upper bound was I less than A.length minus 1. It's the same idea over here because now the array trip length, the length over here is simply just how many. Okay, the same idea. Okay. So which part are you stuck?
I was just kind of just wondering how, because my main concern is the difference between how many. This thing is, so I remember like I had a bit of a doubt, like relating to those.
Okay, for 100% understanding, what about we do this? Okay, let's say add a page below. Okay, let's do this. Let's put a loop again. For integer, remember the string. Let me just recreate a part of the program. The string array, just string array, trip, is assigned to new. And then we have array, string, and then we put how many over here. Right? How many is some integer we read from the user. Okay? That's it. And then over here, let's talk about this loop over here. Okay? What we get is the for loop integer I is assigned to 0. Let's say we do how many only. Okay? So now we got I less than how many, which is exactly what this how many is, right? Exactly the same number. Okay? Let's do that. Let's see what we can run into. I plus plus. Okay? And also we say string, and then we have source city and destination city, right? So we can say source city is assigned to trip array at position I. And also we got another one, string destination city, which is assigned to trip at position I plus 1. Okay, and then etc. Now, let's think about what's going to happen here. And let's also use this example over here, okay? Miami, Boston, New York. If you have your trip array like this, of size 3, so 0, 1, and 2. So we got Miami over here, and then we got Boston here, and also we got New York over here. Okay, let's try to trace this program over here. So we have I, and also we got I plus 1, okay? And then we have the source city over here, and also we got the corresponding destination city. Let's try to trace it, okay? Let's try. In the very first iteration, I is going to be initial value 0. Okay, let's try. So that means 0, I plus 1 would be 1. What's going to be the source city? It's going to be trip at position 0, which is Miami. No problem. And then what about destination city? It's going to be at position I plus 1, which is 1. Okay? It's going to be Boston. So we are pretty much safe for the very first iteration. That's okay. Now, when we get to the second iteration, I will be incremented to 1. Correspondingly, I plus 1 will be 2. We still seem to be okay. Let's just write it down. What will be the source city in this case? It would be Boston versus New York, right? Let me just put it down. Boston and also New York. Now, at the moment, I is going to be incremented further. I plus plus, right? Since you got I plus plus here. So it's going to be incremented to 2. So now, what's how many here? How many basically is exactly trip dot length, right? Because that's how we created that array. So what's trip dot length? 1, 2, 3. 3 over here. And I at the moment is 2. 2 less than 3 is true. That means go in there for another iteration. Now, you can see that from the previous 2 iterations, we already consider what's between Miami and Boston and what's between Boston and New York. That should be enough already. We shouldn't consider New York to somewhere else because New York is already the final destination for the itinerary. We shouldn't go any further, but according to this version here, we should, right? So now, what will be I plus 1? 3 over here. So that means source city over here would be New York. But what about here? In that case, that's going to give us trouble, right? Exactly. So now in that case, let me use a different color here. So what you will give to you is trip at position 3. There's no position 3 over here. There's no. So that's index out of bound exception. Out of bounds exception, yeah. Okay, that's why. So that's why if you simply put how many over here, you go exactly just 1 off the maximum index. But so that's why you should really put how many minus 1. Okay, that's what you should have put. That's why. Okay. Okay, guys, any question about this? It's tricky, but that's something for you as a programmer to reason about. Okay, if no further question about this, what I would like to do is let's go over a number of examples. Again, for the very first one, that's going to be your first loop on the 2-dimensional array to really go through it one by one. Okay, the one we just did over here is a very simple one, right? Given the source, given the destination indices, you can look it up directly. But let's do something a little bit different. Let's say you're given a 2-dimensional array of integers. How can you find out the maximum value in the 2-dimensional array? And how can you find out the minimum? How can you determine if all the values in the 2-dimensional array is positive, etc. Okay, so that's kind of the problem we like to solve. Okay, let's see. Let me just go over some slides, make sure I don't miss anything, and then we'll go one by one. Okay, we are completely done with the motivating example, and this is something I would expect you to know very well already because we talk about the syntax for creating 2-dimensional array. You definitely need that for lab number 6. Okay, And let's now go to, now one more thing I want to mention. For the two-dimensional array, let me just do one more example on the iPad. That's something I want to clarify very quickly. When you talk about the length of the array, in the case of one-dimensional, it's very clear what you really mean by length of the array. But in the case of the two-dimensional array, do we talk about number of rows or number of columns? It can make a difference. Okay? Let me just make a new page over here. Okay. Let's now do the following. Let's say if I have integer array, okay, two-dimensional. And then I would say A over here is assigned to, it's going to be a two-dimensional array. That's how we do in Java. Let's say this. For the two-dimensional array, you can have something like this. Let's say 1, 2, 3. That means for row number 0, I have 3 columns. Okay? Let's introduce a second row. So now, the flexibility we have is enormous. For the second row, the number of columns do not have to match the number of columns for the first row. You don't have to. Let's say we want to make a triangular shape. Let's say I put 4 and 5 over here, and that's it. Okay? And then for the third row, I will put 6 over here. And that's it. This is a perfectly okay two-dimensional array. Okay? And we also, at the end of the example, we also talk about how you can play with such a two-dimensional array briefly. Okay? So now, let's talk about exactly what this array, how this array can be manipulated using nested loop, which will be the next slide. But before we do that, can we figure out exactly how many rows and how many columns there are? That's something we want to see. Okay? So now, we know that this is more like a programming view of the array. Let me just draw different pictures for you. Okay? This one is how you created the syntax for Java. What this will do is, A is going to be storing the address of some two-dimensional array, which is pretty much like an array of arrays. So A is going to point to an array of size 3, right? So we got 1, 2, and 3. Okay? So row number 0, row number 1, and row number 2. For row number 0 is going to point to this particular array. That's for row number 0. Okay? So that's why we can simply say row number 0 is pointing to an array of size 3. Okay? So 0, 1, and 2. Okay? And similarly, for row number 1, which is over here, okay, we can have another array which is of size 1 and 2. 1 and 2 over here. Okay? Column 0, column 1. Finally, we also have another one over here. Okay? That's the third row. And over here, it points to another array of size 1. Right? Okay? Let's just fill in the contents. So 1, 2, 3, 4, 5, and 6. So that's more like a memory view, an array of arrays. If you like, conceptually, that's how you can think of it. Also equivalence. What you can think about is, you can say A is pointing to something like this. 3, 2, and 1. 0, 1, 2, 0, 1, 2. And then also, that's what we have. 1, 2, 3, 4, 5, and 6. So these 3 views are completely equivalent. The first view over here is how you write in Java to create a two-dimensional array. This one over here is more like a memory view to say that a two-dimensional array is basically just an array of arrays. Okay? And this one here is conceptually how you would like to create it. Okay? So you should really know all the 3. Any questions until now? Okay? So now, let's now figure out, given this two-dimensional array over here, how can we know its dimension sizes? Okay? What's the sizes of dimensions? Okay? So now, first of all, the number of rows. How many rows do we have? Basically, you can see that 1, 2, and 3. You can see 1, 2, and 3. 3 rows. But how can we see that? Basically, if you look at a memory view over here, A over here is pointing to an array. The size of that particular array is going to be the number of rows. Okay? Number of rows. Let me just say that. Okay? So now you can say, what you can say is A dot length. That's exactly the number of rows you have. Okay? So I would suggest when you look at that, look at this diagram over here, right? A is pointing to an array over here. Each element of that array is just another array, right? You only get to the further arrays when you want to figure out the column sizes, but not yet. For now, we just want to know the row number. How many rows do we have? Okay. What about the number of columns? Okay. So now for the number of columns, it's going to be a little bit tricky here, because which row are you talking about, right? Depending on which row you're talking about, the corresponding column size can be different. Number of columns. Okay, let's have a look at this. For example, number of columns over here. Now, we know that A0 is pointing to this particular array. We know that. Okay, and the number of columns we have for that particular row correspond to the size of that particular array, right? Which is like this, the length of that array. Okay, but how do we express that? Okay, let's try. How do we refer to this array over here, first of all? It's going to be A, which is an array of arrays, go to the first one, A0. Basically like row number 0. So this is referring to this array particularly, and then we're going to say dot length. Okay, so A dot length, by the way, is 3. And A0 dot length is going to be also 3. Okay, so now what about the column size for the second row? If you say A, and now I want to go to another one, let's say I want to go to, let's say, this row number 1. Okay, in that case, what we will get is A at 1 over here, dot length. And what is that? 2. Similarly, we also got A at position 2, which refers to this particular array over here. And then, if you say A2 dot length is 1. Okay, you can see that over here, 0, 1, and 2 over here, it refers to the corresponding row number for you to figure out the corresponding column, right? Any questions about this? That's why you got 3, 2, and 1 different, right? You got 3, 2, and 1 different. If no questions, the next question for us to talk about will be, given this kind of flexibility we have, meaning that each row may have a different corresponding number of columns for the two-dimensional array in general. So now what would be the best way to go over elements in the two-dimensional array one by one? Okay, let me give you a little bit hints. Okay, just for this particular example. If I want to go over the elements over here one by one, what should I do? Okay, let's just be systematic. I want to go over this, followed by that for row number 0, which means I want to go for A0, 1, A0, 2, and also A0, A00, beg your pardon. Start with 0. Let me just do it over again. Okay, so this one here, A0, 0. How about 2? A0, 1 in the same row. And over here, A0, 2. Okay, after that, we should go to the next row. After the previous row has been exhaustively examined, so now we go to the next one. So how do we refer to 4? It's going to be row number 1. A1, 0. And 5 over here, A1, 1. Okay, finally, we got this one here. It's going to be A2, 0. Okay, so now you can, let me just help you a little bit more. You can see that over here, 0, 0, and 0 over here, they're the same, which means we're talking about the same row, right? And over here, still, You got 0, 0, and 0 over here. That means we're talking about the same column. Questions? Okay, yeah. Okay, so now, apparently you can see that we got two orthogonal issues to handle over here. We got some index to refer to for the row. We got another index to refer to for the column. So now that means we need how many loop counters? We need 2. And we talk about this kind of stuff, right? So that means you want to have the combinations of 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, and 2, 0. How do we do that? Nested loop. Okay? So basically what you need is a nested loop. Okay? Let me just write it down for you. Okay? What you need is you have for integer r is the very first row we're going to talk about will be row number 0. Okay? And then we should have some upper bound for the row. R less than something. I'll put something over here. R plus plus. Okay? So the R here should be able to go over 0, 1, and 2, basically. Okay? That's R. And now, inside for each R, we want to be able to go for 0, 1, or 2 for the columns. We'll only go for 0, 1 for the second row. We'll only go for 0 for the third row, depending on what's the size for the corresponding column. Okay? So now, we need another loop over here for integer, let's say C for column. Also, column size, column value start from 0. And now, also, C is going to be strictly smaller than something over here. And then C++. Okay, and then you can do something inside. Okay, so we have 2 loop counters over here. We have row and we have columns. So now the question is, what should we fill in over here? That's the question. Okay, we have done nested loop in thorough details for last lecture. So now all you got to figure out is exactly what you should put over here. So you say that for the first one, AI the length. AI, what's I? No, we only got nested for loop, only 2 nested loop. There's no I. Well, how many rows do we have? 3, right? How do you figure it out? A dot length. So you don't need an I over here, just A dot length. So now, what about the corresponding C? Let's say currently, if R is 0, that means we should really go for A 0 the length, right? A 0 the length is 3, which tells us we should only go for columns 0, 1, and 2. When R is actually 1, in that case, that would tell us that we only got 2 corresponding columns. In that case, the column index should only be 0 and 1, right? So what should we put over here? Well, A first, right? AR, the length. Yes? No, not -1. Here you got strictly smaller, so you don't need -1. Okay, AR the length. Yeah, but it's good that you think about it. It's good. I might trick you by putting this in the exam, by putting -1. You should really tell that it's actually wrong. Okay? Of course, that's just a warm-up. We're going to talk about this loop in very much detail once more before we get to other problems. So this is really the fundamental part for linking today's lecture and last time. Yes? A are the length. Yes, A are the length. Think about this. The question was, over here, should we put AR the length or AC the length? The answer is R. The reason being, the R over here can be, it must be strictly less than A the length over here, right? A the length in this case is 3. So that means the row number can be 0, 1, or 2, right? So now, for you to know exactly how many columns you have over here, you should really go to AR the length. What about we just trace the program to get a next slide, and then we'll see. Okay, so now, again, so this is the first example over here. It's very easy. The problem is simply just to print out the 2-dimensional array. We'll trace it using this very simple example. It's basically an array of 1, 2, 3, 4, 5 elements there. We got 2 rows. The first row, row number 0, got 2 columns. And row number 1, we got 3 columns. Okay? So in total, we should get exactly 5 times to go over the elements. So what I want you to look at is over here. You can see that we got, let me just use other color here. So you got row here. Okay? That's it's pretty much like an I that we talk about. And also we got over here column. So we got 2 loop counters. Feel free to use I and J if that makes you feel more comfortable. I just use R and C for row and columns. And then I want you to look at the upper bounds for these 2 variables. Let's have a look. The first one over here, you can see that we simply use a.length. Okay? For this particular example, what's a.length? 2, right? A is referring to this array over here. So a.length is 2. Okay? We know that it's 2. Okay? And then in the inner loop, starting from line number 3, it's going to be a little bit trickier here because depending on where you are for the row value, the column value is going to be different. If you're currently at row number 0 over here, the corresponding column number should be 1 and 2, should just be 2, right? Size will be 2. If you are in row number 1, the column size should be 3. So it depends where you are. So that is why you will see something like this, a row length. Okay? You can see the row over here is the current value for this row over here. That's the trickiest part for running a loop for 2-dimensional array. Okay, so the way I'm going to trace this is by, first of all, let's draw the flow chart for this nested loop. Okay, we have seen this already. There's nothing new on the flow chart I just drew over there. That's why I drew it first. We don't have to go from scratch. Okay, let me just remind you very quickly. When we did our nested loop last time, remember this loop we did together? That's exactly what we did, right? Basically, I is right now like a row, and J is now like a column. Okay, the same, similar exercise. Okay, so I'm going to skip the detailed parts of how to draw from scratch, but it's something you should do as an exercise for yourself to keep track. What I will do is I will go to our diagram over here, and then just go over with you very quickly. Okay, and then we'll trace it. Okay, so now let's go from the beginning over here. Let's say over here, let me just put over here row, and also we have column. Okay, let's only get row and column over here, right? We'll see exactly what's gonna be the combinations of row and column that we're going to use in order to print out the elements. And you notice that line number 4 is really what's similar to how we access the distances table from before. Given a row, given a column, we're going to print it out. Okay, let's see exactly how we do that. Okay, so now let's now see exactly how we're going to do that. First of all, initially we're going to execute the first statements over here. Row is assigned to 0, so row is going to be 0, and then row is now going to be 0, 0 less than a.length, which is going to be 2 as we said. 0 less than 2, which is true. Okay? Good. Thank you. So now, if you got, yes, so you got 0 less than 2. Initially, row is simply 0, 0 less than 2. It's true. That means we go into this branch and then we print out row and then row, right? So that means we'll print out row 0. Okay, that's for the very first iteration for the outer loop. And then we'll initialize the column number to be 0. So that means column is going to be 0 to begin with. And then now here comes the interesting bit. When we have column less than a row length, what's going to be the case over here? We know that row is currently 0. A0 length. A0 length is Don't you agree? Okay. A0.length over here, the whole thing is going to be 2. Okay, so colon at the moment is 0 over here. 0 less than 2, true. Okay, so now we go to print out A, row and colon. So we print out A, 0, 0. Okay, and what's going to happen next? Next, we reach the end of the inner loop, so we increment colon with a colon plus plus. So that means row number remains to be 0 over here, but colon get incremented to 1. Okay, it gets incremented to 1, and then remember we actually go back over here to check. So after getting incremented, we go back to the state condition over here to check. So now we know that colon has been incremented. Let me use a different color here. So colon has been incremented to, used to be 0, and it's now 1. So now 1 less than 2 is true, right? In that case, we still go into this branch over here, and then we print out A, row and column, which will be 0 and 1. So far we have tested 2 combinations, 0, 0, and 0, 1, right? Okay, what's going to happen next? Column plus plus, which is going to increment the column number from 1 to 2. Okay, so now 2 less than 2, false. What does that mean? If you get false over here, that means what you're going to get is, you're going to get false over here, which means you're going to go to, think about what's going to happen here. I'll give you some idea from the loop, the code over here. So this is the inner loop, okay? As soon as the state condition here is false, that means you're going to exit from the loop. So you should go outside the loop and go to the next line, okay? That's basically what you're going to do, okay? And then we just print a new line. Okay, that's okay. Just whatever you want to do. Okay. After that, we're going to reach the after line number 6, which is going to print a new line. We reach the end of the outer loop, which means we're going to increment row by 1. Okay. In that case, we're going to go back following this path over here. Going to go back over here like that, and then row number is now going to be 1. Okay. So that means row number is going to be 1 over here. And notice that one of you asked me the question about how many times are we going to reinitialize the column number here. Depends on how many rows there are, right? So now over here, we're going to reinitialize the column to be 0. So now over here, so row number is now 1. So which means we are figuring out what's A1, the length. It's a different value, which is 3. Okay, so now initially the column number is simply just going to be 0, right? Let's just predict what's going to happen. It's going to be 0 and then 1 and then 2. When it gets incremented to 3, it's going to be exactly not strictly less than that. So we're going to exit from the inner loop and then go back to the outer loop, and then it's also going to increment the row number from 1 to 2. And then 2 less than 2. Also, it's going to be false, so we exit from the outer loop as well. So you will see exactly that's what we're going to print out. We will get basically 0, 0, 0, 1, 1, 0, 1, 1, and then 1, 2. So that's exactly how we're going to print it out using a nested loop. Again, the most important phrase, programming phrase, is over here. Let me just highlight it with a different color here. This is the most important one. Depending on which row you are currently, you're going to figure out the corresponding size of the columns and then use it as an upper bound for the column loop counter. Guys, any questions? Are we okay? Okay. Hopefully it's not too bad. Okay. Given that example 1 we did pretty much exhaustively, for all the remaining examples, I'm going to assume, of course you're going to study this before I can assume. I'm going to assume that you are quite familiar with this kind of patterns. And this pattern will just be reused over and over again. The only difference is, for different examples, we may just have to introduce some extra variables or to introduce some extra computations to achieve the purpose. We'll see. Okay, so now, the first one. This first one is very similar to what you did previously. If you're given a one-dimensional array, how do you calculate average for all the elements? Why don't you just go from A0 until A dot A and then A length minus 1, right? Similarly over here, since it's two-dimensional array, let's see what we know already. We know that pretty much every time if you got a two-dimensional array, if you somehow want to go through the array one by one, you can see 4 and 4 over here. Row 0 less than A length, and column 0 and less than A row the length. Exactly what we talked about before. Okay, this part I would say pretty much standard. Sometimes you may have to do some slight modification. Okay, sometimes. Okay, so now what we do is we introduce some extra variables to it. Okay, so what we do is we have to introduce some total. Let me use a different color here. You got total, and also you got a number of elements. Okay, we want to count exactly how many elements there are in the two-dimensional array. For example, in this case, let's say for A, how many elements do we have? We got 1, 2, 3, 4, and 5. We got 5 elements there. And then what should be the accumulated total for all of them? You're going to do 3 plus 1 plus 7 plus 5 plus 9. Okay? And once you have done that, you can calculate the average accordingly by using some cast, right? Because if you want to print out the value with precision or return the value with precision, make sure one of them is a double, right? That's what we talked about before, okay? So now this one here is really nothing very difficult. I just highlight it to you. Over here, you can see that over here, every time inside the inner loop, we have to accumulate total plus equal A row column, right? So basically, let me just do one for you. For the very first iteration, we're going to have total plus equal A, 0, and 0, right? And then the next iteration will be A, and then 0, 1. Okay, you just keep accumulating, and then you will say plus equal A, 1, 0, and then 1, 1, and then 1, 2. And of course, you got total over here, right? That's exactly how it accumulates. And notice that we also accumulate the number of elements to see exactly how many we get, right? You just use plus plus, and eventually just use the division over here to calculate. This one's really simple. Any questions? Any further explanation needed here? Are we okay? Okay. Okay, that's the second example here. What about the third one? Okay, maybe I should really show you the slides because maybe you don't want to see the solution so quickly. I should give you some time to think about. Okay, let me just go back to the slides quickly. Okay, what we just did was this one here, print out everything, and this one over here, just to calculate average. This one is simple. If you haven't looked at the slides yet, let's think about this problem over here very quickly. Given a two-dimensional array, which may not have the same number of columns for each row, right, in general, I want to find out its maximum and minimum values. Maximum and minimum. We have done this for one-dimensional array. So now how do we do that? Okay. Let's now, I'll give you maybe 20 seconds to think about it, and then I'll go through some idea with you, okay? I just want to give rid of the solution from my iPad, so I just show you the diagram. Think about how you would do. Let's now take this array as an example. How do you find out its minimum and maximum? Well, if I simply just ask you what should be the minimum and maximum for, let's say, only this array, you know pretty well. You basically say, maybe I will take the first element to be the minimum or max. Let's say we calculate the maximum, okay? Let's say we take the first element to be the maximum to begin with. And then we go on until the end of the array. Every time when we see a new element, we compare that element with the current maximum we have maintained. If the current element we're looking at is strictly larger than the current maximum, we replace it, right? That's how we did. Similar idea over here. You can think about somehow the nested loop that we talked about before is going to systematically go over the two-dimensional array element by element in the sense that row by row, column by column. In a way, it's also like a flattened out linear array. Okay? So now how do we do that? The idea is very simple. Again, let's say, let me just undo this. What you can do is, what about we say, we make this guy over here a 0 and 0, which is 3, to be the maximum and the minimum at the same time. Since we're going to find out the maximum and minimum. Let's say you have a variable called maximum, and you also got a variable called minimum. Eventually, you want to print these two out. Okay? If, in the beginning, both are just 3. And then we kind of run the nested loop that we talked about to go over row by row, column by column. Okay? When we first look at, and then let's say we start from here. When we look at this element over here, the second one, right? Should we update the maximum or minimum? We should update the minimum, right? Because you can see 1 is not strictly larger than 3, but it is strictly smaller than 3, right? So that means we got to update that. In that case, we'll do 1, like that. And then first row finished. Then we go to row number 1, okay? Index 1. And then we, first of all, we see this 7 over here. So now we should update the maximum because 7 is strictly larger than maximum. That's what we care. So update that to 7. And then we go to the next one. We got 5. 5 is neither strictly larger than maximum nor strictly smaller than the minimum. So we don't care. Okay? Go to the next one, the last one. Over here, 9 should be updated as the final maximum. So finally, we return 9 as the maximum and 1 as the minimum. Basically, we'll still follow the same pattern of code as before. The only difference is we introduce different variables in this case. Okay? Let's see how the code is going to look like. Okay? That's how the code is going to look like. So now, again, we still have this nested loop over here. For loop. We got row and column, a.length, and also a row.length. Okay, pretty much standard. I wouldn't suggest you memorize it. You really want to understand why we put a row.length. Okay, and then we basically, and every time, if you want to see what's the current element we are iterating through, a row column. Okay, that one is pretty much standard. So what's really specific about solving this particular problem over here? So let's have a look. Over here, let's say we got maximum and we got minimum, right? Outside the loop. So that means we can keep reassigning to these two variables when necessary. Okay? Initially, we say maximum is a00, minimum is also a00. Pretty much like what we did before, right? Initially 3 and 3, right? And then every time when we got a specific value to go over, we want to check if it is either strictly larger than max or strictly less than min. Either case. If that's the case, you can update the max or update the min. And that's it. Right? Any questions? Yes. The question was, is it possible to, I see what you mean. The question was, since we know previously how to calculate the minimum, let's say maximum, okay? Since we know previously how to calculate the maximum for a one-dimensional array, is it possible to save some work by calling that as a helper method? I would say that's possible. That's possible, yes. Let me sketch the code. Let's try, okay? So now, let's assume, it's a good question. Very good question. Let's assume the following. Let's say we have some method over here, integer maxOf over here, and then we simply pass an integer array, one-dimensional. Let's say integer array, Let's say this already is implemented. Okay. So now, how can we? Oh, notice that. How do we implement this? By using a loop, right? We agree on that. So now, how do we somehow simplify our code? Simplify the code structure above to calculate the maximum for the entire two-dimensional array. Let's try. Okay. This is what we can do. Actually, I like this question a lot. I haven't thought about it. That's good. So now let's try this. Basically, we're going to still go over row by row, and for each row, call the helper method to find out what's the maximum in that row, and then compare that row maximum with the current maximum. If the row maximum is strictly larger than the current maximum, replace it. Otherwise, go to the next row. Okay, that's basically the idea. Okay, let me do this here. So let me do this. Integer maximum is, let's assume we got at least one row in a two-dimensional array. Let's assume. So now, pretty much like this. The way we did maximum minimum before is to assume they are basically the elements in the top corner to begin with. Let's say now initially we can say the maximum of the first row. Okay? So now, I will go over the example with you in just a moment. Maximum of, and then help me out. What should I pass over here? Notice that IA over here is one-dimensional. A over here is two-dimensional. How can I figure out the maximum of the first row? What should I pass over here? Should I just pass A? Anyone? First row. A0. Okay. Just figure out the first row. And then we can now go over line by line. It doesn't matter which row you can still start from row number 0, you can start from row number 1. Let's say for integer, let's say, I would just say R. R is assigned to 1. Since we already covered row number 0, let's start from row number 1. And then R less than A dot length. And then R plus plus. And now, we can basically go over row by row. We don't have to go to the column level anymore, given that we got a helper method, right? So now, what should we put inside the for loop? Basically, we want to say the following. We want to figure out, for the current row we are looking at, starting from row number 1, let's say we're looking at row number 1. If row number 1 has its maximum strictly larger than the maximum that we did before, then replace it. Otherwise, don't replace it, right? So now, let's see this from the example. According to this example over here, what's going to be the max? 3, right? The maximum for this array over here is just 3, row number 0, okay? And then, for this loop, basically, when R is equal to 1, for the first iteration, what's the maximum for row number 1? 9. Compare 9 with 3, which is larger, then go ahead and do it. Okay, so the code you got to write is something like this. Let's say integer, let me say this. Integer, let's say Cmax for current max is equal to maxOf. Since currently we are looking at row number R. Okay, so what we can do is we can say maxOf A R. Okay? And then, you want to suggest how to finish? Give some suggestion. Maybe not modification. Okay, we talk about modification, maybe off, yeah. That's okay, yeah. I see what you mean. But in your case, you are trying to create an auxiliary array, right? I'm showing to you it's not really necessary. You're saying that you put all the row maximum into a single array and then find out what's the maximum in that particular array. I can show you you don't need that. Yeah, okay, that's okay. Yeah. Don't worry. Yeah, go ahead. If statements, help me out. If statement is important, so I'll put red. If Cmax is greater than max, and what do we do? Absolutely. That's it. Right? Because let's think about what's going to happen here. The max over here in the beginning is simply just 3. And then the Cmax that we got over here is 9. So you can think about max initially and also Cmax over here. Because we see that Cmax is strictly larger than the max, we can replace it, right? Just got max over here. But since we only got 2 rows, so we are done. Okay? Guys, you may have the illusion that this code is simpler. But think about what's going to be the necessary computations that's going to require. Are we really reducing the number of requirements, required computations? Not really. Because as I said before, think about what's really required to be done for this particular method, helper method here, maxOf and maxOf. Itself is going to be a loop inside this loop over here. So it boils down to be exactly like this. But I like this solution over here because you're reusing what you did before. Okay? Questions? Okay? Yes? Sure. It's like a helper method call. No. Oh, I see what you mean. So now, okay, don't get it confused. I see what you mean. No, it's not really calling itself. Let's clear the context over here. So now you can try this. I encourage you to try. Okay. Let's say, let me just be precise over here. You got class, let's say, test, maxOf, for example. Okay. Let's say over here, you know what? Let me just say a little bit closer to how you would do in lab test 2. Okay? Utilities. Okay? So now, the maxOf is going to be some method you define over here, integer maxOf. Integer, one-dimensional array, IA, over here, and then you do the normal stuff over here, right? Okay, good. So far, so good. And then the method that we are talking about over here is just another method. It can be with the same name, or it can be with a different name. Okay? So now let's say this. If I simply say integer maxOf, which is totally okay, you can try. Okay? If I put integer array over here, IA, that's exactly what we're trying to do over here. Right? So now, back to your question. You were asking basically, when I say maxOf over here, am I trying to call this maxOf over here? The answer is no. Because you can see that the input type over here, integer array, one-dimensional, versus integer array, two-dimensional, they're totally different. So the compiler would be able to tell. Okay? So now, let me just be more precise over here. So now maxOf, the green parts, is going to call exactly this maxOf. Okay? And what we are trying to define in this current context is just another method. maxOf. It's different. Give it a try. Yeah. Guys, you should really try to learn actually from your colleagues. I think his question was very good about reusing what you learned before. Absolutely. Yeah. Any questions before I move on to the next one? Yes. Wait a moment. I want to make sure I properly hear you. What if? What you mean the number of columns, or what do you mean?
No, the number 9 at the...
Oh, 9 over there?
Yeah, in a cell of 3 we have 9. Like 2 maxes. So what we have for 4.
Oh, you mean over there we got...
In a cell of 3 we have 9.
Okay, I see what you mean. You mean that for the top corner there, we got 3, 1, rather than 3, we got 9, 1. Okay, good question. The question was, I'm going to illustrate. It's a very good question. What if we have some duplicates in the array, which is totally allowed? Okay, let's try. So let's hypothetically assume a different array. Okay, let's now say, let me wipe this out. What if this is 9? That's your question, right? Okay, very good question. Now, let's walk through the code again for this one here. So now, what's going to be the max? It's going to be the max of the first row, which is 9 still. And again, and also, what about for the very first iteration, when we go for row number 1, which is here, over here, and then what's going to be the C max? Also 9. We got 9 versus 9. So now, C max, which is 9, larger than current max, which is 9. 9 larger than 9, false. What does that mean? That means the current maximum you get is not big enough for you to replace the maximum. So the current maximum remains to be 9, which is okay, right? So that means you still get 9. So nothing wrong there. But it's a good question because our method over here does not have any assumption about that you don't have any duplicates in the array. You will just work still. Yes? Yeah, absolutely. So the question was, what if we change the question a little bit, which I would like to give you as an exercise, okay? So now, what if we say that rather than finding the maximum, what about we want to find out the minimum? I can tell you that you can basically copy and paste the code, changing just one thing, a single character. Can you see what a single character is? Oh, yeah, less than, yes. Exactly. The bigger sign to less than. If you're picky, you can also rename the variables. That's another thing, okay? Okay, guys, exercise for you. How do you calculate minimum of? That's also an easy question, okay? Okay, good. Okay, that's about the third one. You know what? I think the third one is quite nice. This kind of small extension that will help us solve the fourth example. Okay, let's go there. Okay, I tell you what, this is the most difficult one, okay, out of all the examples I'm going to give to you. Okay, let's cover this one also properly. Let's read it together. Given a two-dimensional array of integers, find out the row which has the maximum sum. Let's try to understand from this English sentence over here. What does that mean? You got several rows in your two-dimensional array. Each row has some particular sum. Find out the one with the maximum sum. And let's clarify something. The row with the maximum number of columns doesn't necessarily have to have the maximum sum. It doesn't have to be, okay? And let me just pause at this at the moment. I don't want to show you the code directly. Let me just, give me just 20 seconds, okay? I'm gonna copy the diagram from our iPad to another new page so we can think about it. This one is really interesting. Okay, bear with me, just 10 more seconds. Okay. Okay. Now, let's look at this array over here. Slightly more complicated than what we did before. We have 4 rows, and each row has different columns, right? That's intentional, okay? So now, let's see exactly conceptually what's going to be done, okay? Let me use maybe red over here. So now, if you look at row number, maybe different color here. Let's say this is row number 0 over here, and what's the sum of all the elements there? It's easy, it's just 29, okay? What about row number 1? Row number 1 over there, let's say blue one over here, the sum would be, let me see, 38, right? Let me know if I'm wrong. I could be wrong. 38. Okay, good. And then the third row over there, let's use pink. And the third row over there also has a sum, even though it has only one size. That's okay. By the way, the row can even be empty. Okay? So now in that case, pink, that'll just be 41. Simple. Okay? And then finally, the row over here, let's use orange. Over here, has 4 elements there, and the sum will be 40. Okay, I don't have orange here, but I'll just use a different color here. Let's say 40. Okay, so you can see that this is the sum for the first row, sum for the second row, third row, and fourth row. What's the maximum? 41. So the answer is row, sorry, this color is not very readable. Let me just use this. So what you would say is row number 2 has maximum sum 41. Apparently 2 has to be determined and 41 has to be determined as well. That's the problem. Anyone not really understand what the problem is? This is the problem. Okay? I would say this one is slightly more difficult than the maximum and the minimum, but the idea is very similar. What we did before was we have some temporary maximum, and then we compare every element in the array to see if we should replace it. Now, the frequency of replacement should be lower because we only get a chance to replace the current maximum after we calculate what's the sum for the current row, right? Rather than for every element. Okay? So now, why don't you just try to think about what's going to be done? Think about it for just 20 seconds or so, and then I will go over with you the code. Again, we're going to basically follow the standard templates for two-dimensional arrays with some additional variables to manipulate. Okay? I'll give you a little bit hints. You can try to sketch some idea. I'll give you a little bit more time to think about. Okay? I'll give you a little bit hints. Basically, if you refer to what we did before, we got maximum, right? So now you basically you can say integer. You can still say maximum, but let's say to be more precise, you can say maximum sum. But what should that be? Okay, that's one question. And also you have an integer. What about maximum row? The row with the maximum sum. Eventually, maximum row should be 2, and maximum sum should be 41, eventually. Of course, we'll keep updating these two variables when necessary, okay? But the thing is, how do we initialize these two variables? That's the first question. And then, once we initialize these two variables to be some appropriate values, how do we go about iterating through the remaining parts of the two-dimensional array? How do we do that, right? That's a question. Okay? That's why I said this one is a little bit more trickier than the previous one, but it's not too bad. Think about it. The hint is you need these two variables, at least. Yep. Due to the time constraint, if you have some thoughts, keep it to yourself, unless you have some conflicting ideas with mine. That's okay. Okay. So let's go over the solution. Okay. This one really spend some time looking at that. Okay. So here's the idea. Basically, we are still going to run the nested loop, but every time we're going to somehow calculate what's going to be the sum for the current row that we are looking at. That means we have to somehow accumulate the elements, for example, 15 with 14. And then figure out the sum should be 29, right? And then compare with what's the maximum sum so far, and then to see if we should replace it, etc., right? When we get to 38, we see that 38 is larger than 29. So the maximum sum should be replaced by 38, and the row with maximum sum should be replaced by 1, right? Etc. That's kind of the idea. Okay, so now, the problem is, where should we introduce the variables, and where should we update them? That's the tricky part, okay? Let's look at the solution. Okay, the same array over here. Okay, so now I want you to look at, let's now, first of all, look at the variables I talked about before. Let me use this one here, okay? First of all, maximum row, maximum sum. So these are the two variables that we need, okay? Of course, eventually, you're going to use these two variables to print out or to return, okay? These two variables. So now, line number 2, it's about how you initialize these two variables. You can see the complication is the way we initialize max and minimum is simply by using A00, A00. But now, the way we initialize the maximum sum and maximum row is actually by running a loop. So that's where the complication comes from. Okay? The idea is we're going to treat the first row to be the row with the maximum sum. Okay? So now I'll raise some comments over here. treating or pretending, treating row 0 to be containing the maximum sum. The maximum sum. Okay, that's the idea. Okay, so that's why you will see that this entire line, I'll try to highlight it for you. You can see that over here, you can see colon. I want you to look at this, the entire loop, this line here. The green line is a for loop. Okay? What you really want to notice is, since we're only considering row number 0, that's why you see that 0 over here, right? We want to see how many columns there are for the row number 0. And also, maximum sum initially is going to be accumulated by row number 0 only. Okay, that's how we calculate. So now, at the end of the for loop at line number 2, let me put it here. Maximum row, and also maximum sum. Of course, initially we just put it to be 0. Let's be complete. 0 and 0. And then, that's line number 1. After line number 2, what we will do is, we'll go over the first row over here, and then we'll simply just accumulate the elements from row number 0. So that means we get 15 plus 14, 29. Okay? And then the maximum row remains to be 0. Okay? So what does that mean? That means over here you can see 0 and 29 is where we start. We assume that row number 0 over here has the maximum sum 29. And then later on we're going to go from row number 1, right? Because row number 0 has been considered already. Go from row number 1, and every time we reach a new row, calculate the sum. If the sum is strictly larger than the current maximum sum, replace it. Otherwise, go to the next one. Okay, that's the idea. Okay, so now let's see that. And now the remaining loop is very similar to the standard. Let's go over that. So you got row over here, you got column here. Notice that the starting value for the row is 1 because we have already handled the first row, index 0. Okay, you got row and column here, less than a the length and less than a row the length. The similar same as before. Okay, now it's very important for you to see something here. Notice that between line number 3 and line number 5, we have integer sum is assigned to 0. So what does that mean? That means in each iteration, in the start of each iteration for the outer loop, we're going to reinitialize the sum for the current row. Okay? Later on, I'm going to have a question for you. Okay, I'll put it down. It's also on the slides. My question for you is, can we move this line over here and insert it? Can we simply remove this line over here and put it here? No, yes, that's good. How about ask your opinion at the end, okay? And tell me why not, okay? Okay, I'll ask you later. So now over here, let's say the inlet loop here. So we simply accumulate the sum. So the sum over here is sum for row, right? Row is the index over here. Okay, and then we say that if the sum is strictly larger than the maximum sum we got so far, and do the corresponding replacement. Okay, now you can go over the code and try to run it, and maybe it would be even better if you enjoy the flow chart for yourself, help you understand. So let's go back to the original question, which is even more important. So now question, I'll be precise. Questions for you. What if we move line number 4, which is this line over here. Okay, line number 4 to between line number 2 and line number 3. Here, exactly. So right before the outer loop. So what does that mean? Answer. No, instead of telling me exactly don't trace the program for me. Just tell me what's going to happen for the sum. Is it still going to maintain this, calculate the sum for the current row, or anybody? Sum of everything. Exactly. Yeah, I'm pretty sure that's what you want to say, right? Be careful. If you simply move the sum over here, the sum over here to here, it's going to be useless because every time when you try to accumulate, you're really not trying to accumulate for the current row, but the entire two-dimensional array. Okay? No. Then sum will be summing up all elements of 2D array. More precisely, you can see that in the correct version, after we are reaching the end of the row number 0, we have got sum being 15 plus 14, which is 29, right? And then we actually go to the beginning of the inner loop, and then we reinitialize sum to be 0 again. If you didn't do it, that means you're going to accumulate it even further for the second row, for the third row, for the fourth row, etc. Okay, that's why. So it's really important that you understand why it is not okay. Again, in the exam, I might give you this version over here, not the correct version. I will ask you to trace. Okay, so you really want to get it done, get it understood. Okay, let's see the next one. I would say that's the trickiest one for the series of examples over here. Okay? Okay, that is exactly the question I just presented. Okay? Okay, this one over here is also very easy. We have done this kind of problem for many times, right? So now let's just go over the example here. Given a two-dimensional array of integers, determine if all the elements are positive, right? Let me just go to the solution directly over here. Okay, I'm just going to trace, and not really trace at a very high level. Okay, now I want to show you that I got two versions for you to study. Okay, we have done these two versions for many times. Again, the way we do the loop counter is exactly as before. Now, first version, so in both versions we say all positive to be true, and we talk about why this has to be true, right? For empty array, you just cannot find any violation that it is not positive. That's why it should be true. Now, in the first version, we say that all positive is going to be accumulated by using conjunction, right? It can be accumulated by to itself. And then if the current element we are looking at is positive, right? That's the first version. Which means it doesn't matter if it's either there's at least one negative or all positive. You will always go over all the elements. Let's just go over that very quickly. So now, let's go for the first version. So that's why I say no early exit, which means even though you find out there's some negative number there, you still go over the remaining parts of the array. Okay? So now, we go over 1 positive, 5 positive, 3 positive, 4 positive, 2 positive, and 6 positive. So the all positives keep getting accumulated to be true. Okay? Now, let's see the second example on the first version. Let's say we get 1 here, and then when we get to -2, this part here is going to give us false. That means all positive is going to be false. However, it's not going to cause the loop to exit. No, it's not part of the state condition. That means even though -2 over here is already negative, but we will still go over through the remaining part of the array. We'll still go through them, which is accumulating the result. Okay? So that's a version with no early exit. But for this example over here, we do want to exit for efficiency reason. We want to minimize the number of iterations. So now, as soon as we hit something that's not positive, we can exit from the loop. So how do we do that? The way we do that is, let's say over here, we want to say include all positive as part of the state condition. To say, as soon as all positive becomes false, it's going to make the state condition for the inner loop and outer loop false, and then you exit. Okay, let's see how this is going to do. For the original example here, let's say we get 1 here, positive, and -2, which means this part is going to be false. As soon as all positive has become false, it's going to make the state condition over here being false. So we're going to exit from the inner loop. And then when we go back to the beginning of the outer loop, all positive is false. And conjunction with whatever is also going to be false. So we also exit. So that's it for the second version. You can see that we minimize the number of iterations. But in the case where there's no positive, you still have to go over all of them. Okay? So I really want you to study these two versions carefully. Again, if you really want to see the whole story, go back to the loop lecture and see the summary of the 4 versions we have. Okay? It's really important. Okay? Okay, let's see. How are we doing? What's the time now for your watch?
That's around 4:22.
Oh, actually, I'm running over time, right? Okay, guys, just give me 1 minute. Okay, let me just stop the recording and I'll talk to you about this. Actually, for people who watch the lecture, I should let them listen as well, right? Okay, so what's going to happen is, so on Tuesday, they're going to return to the bargaining table between QP and York. But I can see the process may not be as soon as we might hope for, but I would say for now, your priority, make sure you get ready for lab test 2, because as soon as we return back to normal, we got to start with lab test 2. Okay, that's number 1. Number 2, for those of you who have not even started with lab number 5, please start. Okay, and I'm going to release lab number 6 on Friday. Okay, so now, once we go back to normal after the strike, I'm not too sure how many more weeks we might get. Depending on how much time we might be getting, I may have to modify the grading scheme a little bit. But let's not worry about it for now. I will discuss with you guys before I make a decision. But for now, just assume everything is going to be run as normal, just like original planned. Okay? Okay, keep checking your Moodle announcements.